Hey everyone, welcome. Today we're going to dive into one of the most powerful ideas in all of programming, C++ classes and objects. Seriously, this is the concept that lets us go from writing simple lines of code to building our own little world of custom, intelligent components.
But, before we even touch any code, let's think about something a little more practical. Just imagine you're running a factory. How on earth do you build 100, maybe even 1,000 identical, really complex things and make sure every single one is absolutely perfect?
Well, the answer is pretty simple, right? You don't build each one from scratch, hoping for the best. You start with one perfect blueprint. Now, I want you to hold on to that idea, the blueprint, because it is the master key that's going to unlock everything we're about to talk about.
Okay, so here's our game plan for today. First, we're going to figure out what this whole blueprint for code thing actually is. Then, we'll take it apart piece by piece to see how it works. After that, we'll bring our blueprints to life and then see how we can get our new creations to work together. We'll even look at their entire life cycle from birth to death, and for the grand finale, we'll teach them some amazing new tricks.
So what do we call this blueprint in the world of C++? We call it a class. And just to give you an idea of how important this is, C++'s original name was actually C with classes. I mean, that tells you everything you need to know, right? This concept is baked into the very soul of the language.
So here's the formal definition. A class is a blueprint that you, the programmer, get to design. It's your way of taking all the related information, the data, and all the actions you can perform with that data, the functions, and bundling them all up together under a single tidy name.
All right, so let's pop the hood. Let's really get in there and take a look at the anatomy of this blueprint. What are the essential parts that make up every single C++ class?
It really boils down to three key parts. First, you've got your data members. The best way to think of these is as the materials list on your blueprint. They're just the variables that are going to hold all the information. Then you have member functions. These are the instructions. They tell you how to actually use those materials. And finally, and this is super important, you have access specifiers. These are the rules that say who gets to see what and who gets to do what. Now, this is where things get really clever. Think about the stuff you mark as private. That's like the internal mechanics of a car, the engine, the transmission. They're absolutely essential, but they're hidden away where only the class itself can touch them. This is a critical safety idea called data hiding. On the flip side, you've got public members. These are the user controls, the steering wheel, the pedals. They're the parts that everyone outside the class is allowed to use to interact with it.
You know, a blueprint is great, but it's just a plan on paper, right? The real magic, the real fun, happens when we actually use that blueprint to build something real that we can use in our program.
And creating one of these things, which, by the way, we call an object, is incredibly simple. It's just like declaring a regular variable. So if our class, our blueprint, is called student, then this one line of code, student S1, actually goes ahead and constructs a real object named S1 built perfectly according to our plan.
And once S1 exists, you can actually start making it do stuff. You use this little dot operator to access all of its public functions. So when you write s1.input, it's exactly like you're pushing the input button on your brand new student object, telling it, hey, run your input instructions.
But hey, remember those access rules we just talked about? The whole public versus private thing? Let's say we have an item class, and inside it, the number variable is marked as private. So what do you think is going to happen if our main program just tries to reach in and change that number directly?
Yeah, the compiler is going to slam the door right in your face. Access denied. You are not allowed to mess with the private, internal parts from the outside. The blueprint's rules are strictly enforced, and this is a good thing. It protects our object from being broken or used in a way we never intended. That's data hiding in action.
Okay, so we've got these individual objects, we know how to build them, we know how to use them. The next logical step, right, is to get them talking to each other, to collaborate, because that's how we start solving really big, interesting problems.
Check this out. We've got a function called sum that's part of a time class. Its whole job is to add two different time objects. So it takes in two of them, T1 and T2. And here's the really cool part. Because the sum function is part of the time blueprint, it has special permission to open up T1 and T2 and directly look at their private data, their minutes, their hours, and use that info to do the math. It's a perfect example of objects from the same family working together.
But what about a function that isn't a member of the class? What if it needs to see the private stuff? Well, for those special cases, C++ gives us something called a friend function. A class can basically declare an outside function as a friend, and that gives it a special key to come inside and access its private members.
It's a really powerful tool, but one you use carefully to build bridges between different kinds of objects.
Now, it's also important to remember that objects don't just hang around forever. They have a very clear life cycle. I mean, they're born, they live their life, they do their work, and then they're gone. And C++ gives us special tools to manage their birth and their end.
So, the second an object is created, the moment it's born, a special function called the constructor kicks in automatically. Its one and only job is to initialize the object, set up its starting values, and make sure it's in a good, clean state, ready to go. And you can always spot a constructor because it has the exact same name as the class itself.
This timeline just brilliantly shows the whole life cycle. So watch this. As soon as we enter our main function, bam, 4 alpha objects get created. Then we go into this little temporary block of code, and a 5th one, A5, is born. But the moment we exit that block, poof, A5 is automatically destroyed. Same thing happens with A6 in the next block, and then when the whole program is about to end, the first 4 objects get destroyed. But look at the order. It's the exact reverse of how they were created. Last one in is the first one out.
All right, for this last part, we're going to get into what feels like a real magic trick. This is where we get to teach C++'s familiar, everyday operators, like plus, minus, all that stuff, how to understand our new custom-made objects. I mean, think about it for a second. We all know what 5 minus 3 means. The answer is 2, right? But what should point A minus point B mean? What does it even mean to subtract 2 points in space? Is it the difference in their x-coordinates, the difference in their y-coordinates, the distance between them? C++ has no idea. We have to tell it what to do. And that is exactly what operator overloading is for. It's basically a feature in C++ that lets us tell an operator, like the plus or minus sign, hey, when you see my custom object, this is what I want you to do. It lets us write code that isn't just correct, but is also incredibly intuitive and easy to read.
So in the code we're looking at, the programmer decided to teach the minus operator a brand new trick. For their point class, they defined subtraction to mean calculate the distance between these 2 points. And because they did that, a simple, clean line of code like A minus D is now totally valid, and C++ knows exactly what to do with it. And that's the payoff, right there. We taught the minus operator what it means to subtract 2-point objects. And now, this simple, beautiful piece of code, A minus D, runs our custom logic and correctly calculates the distance between them, 1.97231. We've made our code think the way we think.
And that's the big idea I want to leave you with. The power of a class, of this blueprint, isn't just about organizing data. It's about creating meaning. So if you can teach a computer what subtraction means for a point in space, what else can you teach it? What other real-world ideas could you model? With classes and objects, the only limit, really, is your imagination.